My name is Alexander Starnecker. I'm CEO of Weisser, a medium-sized production manufacturing company based in Germany. And just to get our company to know a little bit better, we do I have to turn this on somehow, or do you? Thanks. And to get our company to know a little bit better, we have roughly 100 plastic injection molding machines. We produce 4,000 different articles. In a total, we produce 500 million parts per year. This is important because of two major figures. So first one is that when I'm referring to a traditional technology, I'm always referring to plastic injection molding. And the second, even more important aspect is that we are an expert in serial production. So we know how serial production works. We know how hard it is to ensure quality over 500 million parts per year. And we know what it needs to be successful, especially in quality and especially in the electronic industry. But let me start with the problems and the issues of serial production first. When we talk about serial production and the optimization of serial production, we always talk about three things. We talk about costs, we talk about time, and we talk about quality. And serial production has to ensure and even optimize all three factors in the production phase. And that's very important if we now switch from our plastic injection molding context to an additive manufacturing context. Because when we go into additive manufacturing, we need to ensure all three factors again. We need to ensure quality, we need to ensure time in terms of delivery time, and we have to ensure that the quality is at least as good as the traditional technology. And let me make a short note on my impression on the AM industry. We have a lot of promises in the AM industry. We have a lot of visions, we have a lot of cases. But the industry, in my opinion, is lacking proof, the industry is lacking products, and the industry is lacking products that you earn money with. And for myself, when I thought what I can tell you here at Formnext, when I thought what would be interesting for you, for the audience, is the fact that it's possible to earn money with products and as a production company in additive manufacturing. And I'm going to show you a lot of examples today how we do it, and maybe it's some inspiration for you, how you might think differently after the speech in terms of additive manufacturing in a serial context. So the first very important statement I'm here to tell you today is that industrial additive manufacturing is already outperforming traditional technologies. So we are already at a point where traditional technologies in certain context situations and for certain applications are already way behind way behind industrial additive manufacturing. One of my favorite examples is the first one. It's a traditional product from our company. It's a spool, it's an electronic part, and very important for you is that's a serial part. So that's a serial end-use part. So that part is going to go into a sensor. Our customer is using it for a certain type of sensor, and we are ready to meet all the quality proposition he needs for this part. So there's going to be a wire on it, there's a lot of temperature on it, it needs to do some isolation here. So very complex in its function, a very complex part. But it looks very much like a plastic injection molding part. And the difference is the quantity. And that's now where it becomes very interesting in terms of additive manufacturing. We produce this as a quantity of 3,000 parts per year. Every year, we are already producing it. I'm not telling anything about cases. I'm telling you something about proof and product. We already produce this, and for our customer, we do this at a lower cost. And that's very simply explained, because when we look at plastic injection molding, you always have to invest in the mold. You always have to pay like 50. In our cases, we are more looking at 80, 90, 100,000 euros per mold before you get your first part. And that makes it so interesting for those smaller quantities, below 10,000, below 50,000 quantity, to go into additive manufacturing if you are able to produce it at the right quality. And the next application we do a lot for our customers is functional prototypes. So this functional prototype, that's a plastic injection molding part. We produce that at a quantity of 3 million parts per year in plastic injection molding. It's a very highly efficient part for an electronic, also a sensor. And what we did here is we produced 600 parts as a functional prototype, not a prototype, a functional prototype. And our customer used this functional prototype to implement his automatization a lot earlier than he could if we had to wait for the plastic part out of the mold. And that's the huge difference. And we talk here about a difference of 6 weeks in terms of start of production SOP. 6 weeks earlier of SOP, that is huge in the automotive industry, in the industry application, industry electronics. 6 weeks earlier SOP is really a lot of time concerning delivery time. And the next part is also a very favorite part of myself. We have a short saying in our company. It's called the MUAMS case, which is short for most unsexiest additive manufactured serial part which we make money off. Okay? That's, if you look at the part, it's just a brick with 4 holes. Okay, it's a very simple part. You wouldn't never expect that to be a successful case in additive manufacturing. But the difference is that this part is originally produced from PEEK. It's a PEEK block, PEEK material, and it's milled out of PEEK. A huge process, very expensive process. PEEK is a very expensive material. We are able also here to provide the same quality. Our products on our machines from Cubicure are able to meet all the quality propositions that are needed for this customer compared to PEEK material. Okay? And once we are able to produce at a comparable quality, it's only a question of cost. And even for this low-end, unsexy, additive manufactured serial part, it's profitable for us and it's profitable for our customer to go into additive manufacturing. I also have some more proofs, some more products, but I cannot show them. I only can tell you the story behind it because those products are confidential now. This part is a totally different case because it's substituting not plastic, it's substituting aluminum. It's a diffuser of fluids, and we produce it also. It has to endure some temperature. Quality is very high. For our customer, we cut costs at a factor of 5. Factor 5 cutting costs because originally it's manufactured in aluminum. It's a lot of engineering, a lot of manufacturing manual work to get this part ready. But in additive manufacturing, we print it at a quite very short time and at lower cost. And finally, our strongest case, also unfortunately confidential, also an electronic end-use part. Okay, everything except from the second is end-use part, is end-use part quality, and is going into products that are on the market and that are used. Okay, and that's also an electronic end-use part. And our customer takes it because he has only low quantities, but he needs that part. And he needs to fulfill his whole product range with this part at a lower quantity. And we are producing here 5,000 parts per year. And I don't know how long you walk around Formnext to find someone who can really tell you that he's producing 5,000 parts per year for an additive manufactured part. That is serial production. That is serial production technology. When we talk about additive manufacturing, we even don't talk about technology, we talk about a process. Okay? And coming back to the triangular of cost, time, and quality, I want to give you another short hint, because that's not all I'm going to present today about proof and products. I have slightly more to tell you. If you look at the triangular, and it has a certain sense why this serial production optimization problem is regularly displayed in a triangular. The problem is that you are never able to be in every corner at the same time. You always have to decide to a certain extent if you want to go in one more or less in one corner. So the very easy example is if you want to increase quality, you have to have higher costs. So you move away from cost towards quality. What has happened in the past 150 years in serial production is that we were able to make the triangular smaller. That's everything that happened, literally speaking. We decreased the triangular. We made it smaller. So the edges come closer to our position. Very easy example.
Ready?
Just compare the just compare a discounter to a luxury brand like 20 years ago and a brand product, and compare it now. They're not the same, but they move closer together. That's only also a short example. So, and the problem there is if we make the triangular smaller and smaller, and that's all we can do in serial production, just make the triangular smaller and smaller, and we pay a lot of money to make it smaller. We lose the possibility to differentiate between our competitors. That's what's happening due to decreasing the triangular. And there's another thing happening. How can we achieve the reduction of the triangular? We achieve that via standardization. But standardization has a certain price. And some of you might already know where this is heading, because standardization has a huge cost part, and because standardization is always implemented at the cost of flexibility. When we standardize, when we talk about serial production, we always talk about losing flexibility. And when we look at the challenges of the world now, when we talk about VUCA world, uncertainties, volatility, flexible supply chains, when we talk about mass customization, when we talk about hyper-personalization, name those mega trends, whatever you like. When we look at those, every single one of these challenges need to be addressed by flexibility. The solution to these challenges is flexibility. And in our opinion, and again, I'm going to show you some proof. In our opinion, additive manufacturing is one of the only technologies, one of the only processes to guarantee and to ensure this flexibility in a serial production context. That's why we say that additive manufacturing is going to add flexibility as a fourth dimension to the serial production process. And now you might going to say, okay, Alexander, you told us a lot of stuff here. Let's show some proof. Let me just explain the flexibility context 1 minute, and then I come to you with all the proof you need. One example when we talk about flexibility is freedom of design. And I think the audience at Formnext, I'm pretty sure you all know about freedom of design. In additive manufacturing, you can produce everything that you think of. You don't have the limitations of the production technology. You can produce whatever you want, just like easy speaking. And you are all aware of this argument. But let me make another point to that. We have the flexibility in the development cycles. And we are experienced that our customers now change their product, although it's already physically implemented. When we look at plastic injection molding, it's very hard to change a product once it is produced. If you change a mold, it costs you a lot of money, it costs you a lot of time. You don't want to change a mold. So the moment you have the physical part, it's already done. You can hardly change the design. But you learn so much if you have the part in your hand. And another thing is something that we experience with our customer, and that is that our customers implement different designs for a longer period of time. So they let 3, 4, 5 designs alive at the same time and make the design freeze a lot later, because through additive manufacturing they're able to have those parts already in the hand and can work longer with different designs and decide at a later point in the development which design they're gonna go with the product. Last important topic when we talk about flexibility is demand orientation. And I know you're a very experienced audience, and you all know demand orientation in the 3D printing context. It means reducing storage, because you only print what you need the moment you need it, so you don't have to put anything on storage. The German railway company is having huge successes with that, and I think you all know this argument. But let me put demand-driven in a completely new perspective. Demand-driven means, in the context of flexibility, demand-driven means that you are able to put your product on the market and see if the market's going to pick it up. So you produce it, you make it ready, you put it on the market, and the market is going to decide whether it wants the product, whether it's going to pay for the product or not. What do we do now? We pay a lot of money in market research, we pay a lot of money in business development, and in the end we put it on the market and are surprised that people don't need it, and paid a lot of money to get it produced. With additive manufacturing, you have lower costs to get the product on the market, and therefore you have more flexibility in ensuring your product success. And if more people would think that way, I'm very sure that we will see more successful products on the market in every industry, but especially in electronics. And for those of you who are from a development department, I think that is something you really want to hear and you really want to need out of additive manufacturing. And then, as I said, I have some proofs for you. So this is a heavy-duty connector. It's a smart connector developed by a company and produced by us. And it has all 3 arguments here. So it's impossible to be produced in plastic injection molding on the one hand. It is, we made a lot of changes, switches in the supply chain within the development phase. And our customer has put those connectors on the market. He produced 100 parts, put it on the market, and now we see if the market's going to pick it up. And the great thing with our technology from Cubicle, we are able to scale it to a large extent. So we are able to scale it on one printer to 6 million parts per year. And the good thing is that you don't have to switch the technology, because when you're able to scale it at an amount of 6 million parts per year, and the customer already bought those products at a certain price produced additively, they will pay more even if you produce 100,000 parts, if you produce 1 million parts, and you don't have to change the price. You can stay in additive manufacturing. And the second one is it's brand new. We launched that together with another customer. It's a health device, and we made the housing, and we had a very flexible development circle. We adapted the housing various times to make it very successful, and in the end have the most successful housing for the product. And also here, we are now putting the product, our customers are going to put it on the market, and we were now able to scale it at the extent the market's going to need it. And that's flexibility, and that's flexibility only additive manufacturing in a serial context can ensure. And I'm not sure how many of those products you have seen so far, and that's really when we talk about success. Let me make one last strong statement. I personally think that industrial additive manufacturing will change the world of production like e-commerce changed shopping. Because what happened in e-commerce, what happened in streaming, the extent of time you spend in the digital world just extended. You just spend more time in the digital world, and you only take the product, you get your shirt, you get your movie, the moment you really need it. And also, again, only additive manufacturing is able to ensure that in a productional context. And I'm pretty sure that's what we're going to see when you talk about the revolution of production. And finally, I hope you got from my short introduction here, you got the impression that our vision works. I showed you proofs. I showed you no potentials, no cases, no use cases, nothing that could happening. Everything I showed you today is already happening, and we have already successfully implemented every product here at the success of our company and at the success of our customer. So there's no potential, it's just proof, it's just product. And the only remaining question for you guys in the audience is now, will you follow us? Thank you very much.